Sudoku degenerates, welcome. Hey, Chinstrap and Ambrose. I'm... Oh dear. Sometimes if you go to Twitch and then check and uncheck, uncheck and then recheck low latency, that catches you up, I think. Oh yeah, let me ping Stu. So I'm going to try another Fortress Philomeno for a little warm-up puzzle. I queued up the Mario Galaxy music because reason I didn't stream yesterday was because I was going to see that movie, and it was really fun. So, for Fortress Philomeno, I divide the grid into orthogonally connected regions and fill each cell with a number, not necessarily single digit, showing the number of cells in the region to which it belongs. Ah, yes. It's an iconic soundtrack. Oh, hey, Andrew Sarkis, welcome. And Senny, hi. Yes, I saw that. Each region must be either strictly larger than all of its orthogonal neighbors or strictly smaller than all of its orthogonal neighbors, and the values on an arrow sum to the value in the attached circle. So this is the sum of these. Already? Yeesh. Also, hi, Screaming Ice Cube. Let's see. Okay, so this... Obviously, this can't be in the same... Now, if these are lows and these are high, and this is high, do I have a problem? No, there might be some issue with this arrow. Oh, yes. Well, these, obviously I have... Yes, I should start here. This certainly helps. Okay, and since this has to be high, it needs to get out. And in fact, this has an upper bound of 6. And it's at least 4 and at most 6. So what... And the highest any of these can be is 3. But interestingly, that doesn't necessarily mean that these are blue. Because I could have a pink 3 here with blue 1s. Wait, no, that would mean... Right. Or I guess I could have a pink 2 here with 2 blue 1s and 1 blue 2. Oh, wait, no, that would cause problems here. Oh, hey, Black Doom. If these are all 1s... Okay, it doesn't work for these all to be 1s. Oh, can they be the same? no. Because they'd be at least 3, and that's... Okay, so we do have this. And in fact, none of these can be the same either. So we got... Okay, so that does give us 2 1s here. And now this is 5 or 6. Now, it's not possible for this to be blue, because you can't have blue in an arrow circle with pink on the arrow head. But there is at least 1 pink on this arrow, and that cannot be it. I am amazed that this can possibly solve with... This needs to be at least 1 more than this. Oh, yeah. Now, this being 3 would be very difficult. But I don't know if it would be impossible. It would mean this is at least 4, so this would be at least 7. Oh, but wait. If this is 3... and this would be at least... that breaks. So we get another 1 here. Now this can't be blue, so it has to get out. And this is either 2 or 3, so it gets out here. Now, wait, if this is pink, this is 3, 1, this is 4, I think that breaks up here, because this has to be at least 3, and it can't be... And if this is 2, this has to be at least 4. Yeah, that's going to... That's going to break. So I don't think this can be 1. Because if it is, like, this is pink, but then these can't touch, so this has to be blue. So now this is 3, 1, makes this 4, which closes this off. But now this blue is at least 3, and this is also at least 3. Yeah, that's broken. So this does get up through here. And now this is at least 5, so it has to get up. Oh, and this can't be blue, or we have a 3 touching a 3. So this is at least 4. Sudoku brain is screaming about how that next arrow could never work. Oh, thanks, Soder. Yeah, if this is 3, then this is at least 4. And this is at least 8. Oh, but that works if this is 5 and this is 3. Oh, thanks. If it's 2, then this is 4. Okay, so this is always at least 8. Because if this is 3, this has to be at least 4, and these two together are going to be either two 2s or this, which I know is at least 4 in either world, 2 of those plus 1, which is always going to, yeah, or even higher. So, this cannot be pink. This has to be blue, this has to be pink. Now this could be oh, could this be 10? Wait. Oh, but this has to get out. Oh, and now this can't be pink because these can't touch. So, yeah, this is always blue. I know this is at least 3, so it gets out here. Now, right. Yeah, the minimum, this is at least 8. It's currently got 5, so it needs 3 more. If this goes, oh, I think I see... Yeah, I think that's all the pinks, and the rest is blue. Now, how do I prove it? Okay, if this keeps going up, this needs 5 more and it can't take it. Okay, so this does get cut off here. So, in fact, we know that we do know these, and thus we know these. So, and since in either world this is at least 4, it must be exactly 4, and this is 2, which resolves which way around this 4 goes. Okay. Nice. Thanks for the GGs. Yeah, this is a cool series. What comes next after this? Alright. Something to try on Monday. Alright, yeah, this, I'm really liking this series. I should set one of these sometime. The drawing these two ones with these, with all these, crossings, border crossings, is, was especially neat. Yeah. Alright, thanks for the GGs, and now it is time for the new rat run. Alright. I don't know what to think anymore. This morning I could see his left hand looked very red, almost like a bad sunburn, and it seemed to be causing some discomfort. At first he claimed he'd spilled boiling water on it while making coffee. I pointed out that he doesn't drink coffee and asked him plainly for the truth. Not just about his hand, but about what he's been working on at night, what SRT means, all of it. After looking shaken for a moment, he asked me to be patient and trust him, promising he will explain everything very soon. Sadly, I'm not sure I believe that either. Yes, Ben's little AI ass Easter egg for April Fool's Day yesterday. Alright. Normal Sudoku rules apply, so every row, column, and box, I gotta put 1 to 9 once each. Aim of experiment. Finks and Finks must both reach cupcakes by finding a path through the maze. The path must not visit any cell more than once, cannot share cells or pass through any thick maze walls. No diagonal moves are possible in this maze. Okay, that does simplify things. Black currents. If two digits are joined by a black current, one is double the other. If two digits are joined by a red current, one is odd and the other is even. If two digits are joined by a golden berry, they are non-consecutive. If two digits are joined by a grape, they have a difference of at least 5, and a digit on a motion sensor indicates how many cells in the up to 9 surrounding cells are visited by a rat. Test constraint. In this experiment, some clues are fake. A fake clue breaks its rule in the list above. All clues that Finks passes through are fake. All other clues are truthful, i.e. those passed through by Finks and those unvisited by either rat. It is to be determined which rat is which. Okay, that's all the rules. So now, okay, so I know that Finks, the clues that Finks passes through are fake, and you can't have, oh, difference of at least 5, not exactly 5. Okay, scratch that. Is it something in here? Like, okay, say neither rat say Finks doesn't pass through here. This is 1, 8, 2, 4 in that case. That's 2, 4, and 8, and... Right, I would need 2 more evens to make this work. So, Finks either passes up here or both. Finks can't just pass through here. So, do I know... Do I know anywhere else where Finks has to go? Doesn't seem... This is a very thematically appropriate theme, given the tension between the narrator and Elliot. So, okay. Oh. Well, there's no way, because there's only, okay. Think of this. As a region. How many ways in and out of here are there? Well, there's one way in and one way out, and I know that Finks has to take at least some cells in there. So, I know Finks goes there and also goes there on her way to her cupcake. So, oh. So these must all have the same parity. Okay. And now, right, Finks must also go through here to make... Oh, wait, could... Oh, wait, no, Finks... If Finks goes through one of these, she goes through all of them. Okay, so now the only question is, does she go through here or through there? Okay. There's also the fact that I can't put the 4 next to the 2 or the 8. So 4 can only go next to 6 in this page, because none of these can be in a 1-to-2 ratio. So there's no 4 here, and there's no 6 out here. Oh, but these must have a different parity, so Finks cannot go through... Okay, so Finks does that. So this is a run of 4 consecutive digits. So this must have a 4 or a 6 on it. And I know this is actually, oh, it's not 3, 6. So this is also from 1, 2, 4, 8. And this is now a 1, 2, 4, 6, 8 triple. So this is 3, 5, 7, 9. And the only two of those that are 2 apart are there, that are at least 5 apart, are 3 and 9. So this is 5, 7. Oh, there must be a 1 down here, so it must be a 2. So that's 2. That's 4. That's 6. That's 8. Okay, so now I know that this does not have a 2 on it. Three, 4, 5, 6, 7, 8, 9. That is going to put some pressure on here. Wait, I know that there's 2 odds and 2 evens. Oh, but that... Oh, so I know that Finks doesn't come through here. Which means that she doesn't touch this cell. Because if she does, the only way to do that is to go through here. So I know that since this is an even and an odd, I know it's correct. So Finks does not... Okay. So this is 5, 6, or 7. Oh, and since these differ by at least 5, this can't be 5, so it must be 6 or 7. Oh, and since Finks doesn't take this either, okay, this is 7, this is 1, 2. So this is 5, this is 7. And this is a 1, 7 pair. So this also doesn't have a 7 on it, which means it is 3, 4, 5, 6. So this is 3, 6, this is 4, 5. Now that doesn't resolve whether this is correct or not, though what's left in here? 4, 6, 8. Can't be 4. Okay, this is 6 or 8. So I guess if Finks comes through here, this has to be 2, 6. For what that's worth. Oh, 4 in this box only goes here. So this is a 6, 8 pair. Oh, this 3, 6 pair looks over here, resolves this, makes this 9, 3. Oh, wait, this is... Oh, this is 9. And this is 8. That's been resolved for a while. Oh, wait. If Finks comes through here, I don't think she can ever get to... Like, if Finks takes this clue, she can't take all of these, but that immediately breaks. So I know Finks does not take this, but she could take all of these, which she'd have to if she doesn't take, which... Oh, well, she wouldn't necessarily have to. Huh. Okay, so I know Finks does not cross between these two cells. Now, is there any... So this is either 3, 4, or 5, 6. Same here. Oh, if this is 3, 4, then Finks has to take this. Which means this is Finks. Which I strongly suspected anyway. And if she does... Oh, I guess I could use uniqueness to show that that doesn't work. But I don't want to use uniqueness unless... Oh, unless Finks also has to take this. Because there's no constraints on where Finks, the original, the one with the one whose name is spelled with an F, can go. So, however I draw Finks's path, the new one with the PHINX, I have to ensure there's only one way for Finks to go. Oh, yes. That helps. Oh, but I don't know if she goes there directly, but I do know... Okay, so now she goes like this, and now... Yes. And now she can't go here. And which means this is accurate, and it can only be 4 or 5. Can't be 4, so it has to be 5. So now she has to go here, which takes that. Okay, so now this is inaccurate. So, these are non-consecutive, but these do not differ by at least 5, so that's less... Oh, these are consecutive, and they can't have a 2, a 5, or a 7. So the only options are 3, 4, or 8, 9. Oh. Sphinx can't go this way. Because how would... Oh, she could go... She could start here and come up this way. Leaving this as the only option for Sphinx. Ah, but wait, that breaks this. Okay. If Sphinx comes down here, where did she come from without cutting off the other rat from the other cupcake? She can't have started here, otherwise Sphinx can never reach this cupcake. So she has to start here, and now how does she get here? Well, the only way to do that is here, and now the only place Sphinx can go is here, but now Sphinx can never enter here, which breaks this motion detector, because neither rat comes here. So this would be a 5, but it can't be. That is very look-aheady, but... I did spot it without drawing all that. So maybe I should use it? Oh, and I know this is an actual... Oh, yeah. There's one down here, and also I know this is an actual thing, so this is not 9. So this is not 8. But also 3, 6, 4, 8, 8, 4. Okay, so this is with a 1, can't go with a 6, so it must go with 2 or 3. If this goes with a 3, 9, 8, 4, oh, that does work. Now, 1 in this box only goes here. I guess this is only 2, 3, 6, or 7. It being a fake motion detector would be... Oh, and since 1 can't go with the 6, where does 6 go in box 4? That's what Soder was saying. Okay, it took me a moment. Okay, so this is a 1, 2 pair. And this is 7, 8, 9. So that's not 3, that's not 9. We have a chocolate teapot triple up here. This is not 2. Oh, and since the max this can be is 2, max this can be is 6. And that's only if this is a 2. What? 1, 5, 8, 9 are left in this column, and none of those go here. So that is much easier to see that Sphinx has to do that. And there's also an 8 in here. Oh, and these have to be consecutive. So this cannot be 1. 5 makes this 4 or 6. It's not 4. 8 makes this 7 or 9, I think. And 9 makes this 8, which doesn't work. Because of that. Oh, and since Finks takes this, she must go here. Oh, and since this is not 6 now, so it must be 3. Because if it was 6, it would be correct, and since Finks passes through it with, that is, yeah, okay. Yeah, it specifies in the list above, and motion sensors are on that list. Just wanted to make sure. Okay, so I have used up... Oh, and this is never passed through, for what that's worth. Now, these are not consecutive. Oh, 1, 2, 3, 6, 7. Huh. Now, how can this possibly be unique? Oh. If like, one of these clues has to be fake. Finks has to come down here. That cuts off Finks from going this way. Now Finks can only go here. Okay. Okay, that... Oh! Right, Finks can't go down here. She has to go here. Okay, so this is also from 7, 8, 9. Okay, so this is 7, this is 8, because it's not 6. Okay, so this is 7, 9. This is from 5, 7, 9. It is 5. Making this 3, 9, 5. Making this 8. And this is going to be a 1, 9 pair. Oh, so this is 7. And this is 6. Leaving 2 and 4 here. Oh. I'm very curious how this is going to resolve. Oh, it'll be something down here, presumably. So, what... If this is real, this is from 2... This is either 2, 4 or 3, 6. Oh. I don't think this can ever be real. Because, okay, if Finks comes here, she passes through it. Oh. Right, a motion detector could also... Wait, no, there's no way for Sphinx with an F to get through, to come through here. And the only other option, like, okay. If a rat comes through there, this is broken because it can't be 7. If a rat comes through here, this is automatically not valid. And I don't think there's any other option for having any, and obviously if no rat comes through any of these, this is 5, which doesn't work. So a rat must go either here or here. But can't start or end there. Okay, so this... Yeah, I think this is forced, and now they're gonna go here. Okay, so Sphinx starts here, and now the only question is, does she take this or not? So this is a legitimate... This is a legitimate black dot, and it can't be 3-6, so that, because that breaks this, and it can't have a 2 on it, so the only option is 4-8, resolved by this, and it also resolves this. Seven in this box goes here, 8 in this box goes here. Okay, so these are all the same parity. So they can't be even, they must be odd. 1, 3, 5, 9. 1, 9. 1, 3, 1, 3, 9. 1, 5, 9. So the fact that these are all odd... Three in this box must go here or here. And maybe I can look at this. This is only 2, 5, or 6. If this is 2, this breaks, so this is not 2. So I guess 2 in this box only goes here or here. But that does... Oh, there must be a 6 on here, for what that's worth. So there's a 6 here. Oh, wait. 1, 8, or 6 on here. So if this is real, it's 2, 4. Ruling 2 out of here. And this can't have 1, 2, or 8 on it, so if it's real... Oh. Well, there's no way for Sphinx to take this. Sphinx could, but Sphinx cannot. So this must be real. So it is 3, 6 resolved by this. Right, and now... Right, now that gets me a 3, 6 X-Wing. So this is 3, this is 6, because those are the only places for those digits in this box. This is 2, which resolves this. Now that does not rule 2, 4 out of here. Okay, so what's left in this column? 1, 7, 9. This isn't 7. Oh, what's left in this column? 2, 3, and 4. So this must be 2, 4. And this is 5, 6, 8. That's not 6. That's not 8. And that's not 5. Okay. Now I know Finks takes this cupcake, so Finks takes this one. And I guess I know by uniqueness that... Oh, well, I know by uniqueness that Finks that one of these has to be false. So Finks has an excuse to come down here and take it, thus forcing Finks to go this way, which means this is a real... But I don't want to use uniqueness. At least not yet. Oh, and Finks can't take this, so this must be legit. This is 8 or 9. It's not 8, so this is 9. Ah. We are making progress. And right, Finks also never takes this. So, what's left in this column? 4, 5, and 7. Well, only one of those is even, so this must be 4 with a 5 or a 7. And that gets me an X-Wing on 4s. That gets me an X-Wing on 2s. Oh, but I only had 2, 6, 8 left here anyway. This is 5 or so. Oh, that's 7. So this is a 4, 5 pair. Oh, that looks left, resolves this, which resolves this. So now what do we got in 2 and 8? Are those resolved? Not yet, but I do get a 2-8 pair. That'll be useful. What about 1 and 4? Resolved by that. And now 5 and 9 resolved by the 5 and the 9 up here. So we got what's left in this is... Oh, thanks, Donatello. What's left here is 1 and 7 resolved by that. And that. So, if Finks comes here, this is 8, which will resolve a lot of things. I guess what's left here is 2, 3, 6, 8. That's not 8, so that's not 6. So if this is legit, then this has to be 8. And he loves Y-sum puzzles? Well, I've not encountered Y-sum puzzles before. Oh, wait. That's not quite a... Huh, okay, so... What am I missing here? Because... I feel like... Oh, I know there's a 3 on here. So, if this is real, this has to be 8, 3, 2... Then, if this is real, this is also real. I mean, I'd pretty much guess that there was trolling involved. Oh, but if... Okay, if Finks comes down here, this is 3, so this is 3, so this is fake, so Finks must also come down here, and then Finks can't get to either cupcake. Okay, that helps. Oh, that gets... Oh, if this is correct, this is false. Right, I forgot, it's non-consecutive. Okay, maybe... Wait, could I have... Right, if this is correct, this is false. So Finks does come down here. So this is always false. So this, okay, that is much easier to... Oh, this is 3, 6, 8, yeah, 8, 2. So now Finks has to come here, so that does resolve this. Oh, and this is legit, so that is... Okay. Thanks for the GGs. Thankfully, the rats seemed to take today's little bit of mischief in the spirit it was intended. Finks was initially mistrustful at being able to go straight to Cupcake, but enjoyed a nice relaxing rest while a friend demonstrated her solving skills. Finks was entirely unfazed by her fake cake when she reached it. She has an uncanny knack for anticipating my little twists. Happily, Finks chose to share her real cake with her, which, if I'm honest, was what I'd hoped would happen. It was rather lovely to see. Aww. I'm glad the bond between Finks and Finks stays strong, even as the bond between the narrator and Elliot... Oh, well, glad you get to experience it here. Okay, well that was neat. I read the rules to this and thought, how could this possibly be unique? But not only was it unique, it was pretty darn smooth. I think it was rated 3 stars on LMD. Oh, this is the previous one. Yeah. 3 stars, yeah. And that was neat. Thank you for the GGs. Okay. I gotta refill my water, but then Chinstrap sent me this. All right. I'll be right back. Alright. Let's play Odd Looking. Set this to try and incorporate path rules that are less used in hybrids. Nice. I do like it when the lesser known rule sets get some love. Ooh, and having hollow grids so the lines show up easier. That is a really nice touch. Normal Sudoku rules apply, so every row, column, and marked 3x3 box got to put 1 to 9 once each. Path. Draw a path along cell edges starting at the red circle in the upper left corner of the grid and ending at the red circle in the upper right corner of the grid. The path cannot cross itself or overlap at a corner. Oh, credit to GDC. Neat. For each edge that is part of the path, the 1 or 2 cells touching that edge sum to an odd total. Okay, so I usually use red just because it shows up better, but it'll also be useful for... Oh, the 1 or 2 cells. So I know this is odd. And so is this. Myopia vision. On an arrow cell, the distance to the nearest path edge is the same in all indicated directions and is closer in these directions than in non-indicated directions. The digit on an arrow cell indicates the total number of cells seen, including itself, up to the path in the arrow directions. If a cell has 2 arrows and 3 as its digit, each arrow sees a path piece 1 cell away. So, like, if this has a 3, then this is path, and none of these are path. Oh, hey, Q! Solving this one, but had a dentist appointment in the way. Oh, well. You get to help here. Okay. This is a max of 4. Oh, and in fact, this can't be 4 because then the path could never reach this. So there must be here, here, or here. Oh wait, no. The path could get out through here and just never takes any of these, or at least doesn't take any of these edges. So 4 still works. Oh. Okay, so, this, I know this isn't path. I know path never gets here, here. Oh, maybe I should make it a different color from the arrows, just... And in fact, in any cell with an arrow, I can X out anything that is not... Okay, for the X's, I will... Okay, and since I've X'd this, I can also X this, because these have to be the same distance. Okay, so this is interesting, because it means... Right, the path never comes down here, because it can never... It would have to take the same... It can't come down here, because it would have to take the same route back up. So that's... Okay, so this is at least This is either 7 or 9. I guess I can remove some of these if I know the path can never, like here. So I think either this is taken or this is taken. It can't be both, because that would lead to a dead end. And I know the path goes this way and this way, so I think that is the path. Okay, and this is even, because I know this is odd because of this. Oh. Path can't come up here because that breaks this cell. It has to be even by this path, but odd by that. So it has to go like that. Ah, and then however this goes. Oh, and it can't come up again, so I know it doesn't do that. But okay, if... Oh, and since this sees... Oh, since this is X, this also has to be X'd, which means the path can never come through here, because it can't get out once it does. Because of all these. Yeah, I should leave all these X's there, just... But this either sees 3 or 4. Let's see, if this closes here, this is even. If this goes down here, this is odd, and this is even. Either of those still looks possible. This is 1, 4, or 7. I guess anything with 3 arrows has to be. Now, the fact that this is in the same column as this means it does have to be different. Oh, and all of these have to be different. Not quite sure how to... Oh. What about this? This is 1, 2, or 3. I can... Oh, now if this goes here... Oh, well, it can't go here, so it would have to go there. The reason it can't go here is because... Wait, how does this... Oh. Oh, wait, no. That doesn't hold. Because if this goes here, it can go up there. This is odd, this is even, this is odd. Yes, yes it is. Oh, so it can't be 1. It can't be 1, because if it's 1, we start doing that, and now this is even by this, but odd by this, and so forth. Okay, so this is at least 3. So this is also not path. True. Anything with 2 arrows is odd. But I don't think I can rule any of these out of there immediately the way I can here. Maybe I should do some parody coloring. In fact, this can't be 3, right? Because if this goes down, this is at most 2, and if this goes here... Oh no, I just said this could be... Yeah, this could still work. Oh wait, no, that breaks the total. So yeah. So yeah, this path does not work. In fact, I don't think this can ever be path. Because if it goes... Because if it does that... How does it connect? It has to do this, but then that breaks parity. This makes this odd, because it's 1, and this even. And then I can't... This has no parity. And the only other option, if it does that, is this, which breaks this total. Which breaks this arrow. So I think... Yeah, these are all done, and this is at most 2. Oh, and since this... Right, so this can't be 4. Oh, wait, this is not X'd out. This can't be 4. Because that breaks this arrow. So what that means is there is something in between here, which this also sees. So I think these sum to 4? Oh, I could take 2 paths there, though. So I can't rule 2 out of here, because one of them could be 1 and the other could be 2. That would be very tricky, but I don't think it would... So what does that say about... it feels like I should be able to prove that, like, if this goes down, I have too many odds in this box or in this column or something. But I don't think that's necessarily... Okay, if this goes here, I know there's one more odd in here. If this goes down here, oh, but there could be an odd out here and an even here. Now, if this goes down, yeah, then I have too many odds for this to go down. But this is odd, this is even. Yeah, I could still have one more. Okay, but wait. Does the fact that I know that there is a... Oh, this can't be 9. Because then this and this is taken, but then how does this ever leave this edge without shrinking that? Okay, so this is not 9. And this is also not 9, just because if it sees the same distance in all of these directions, the max it can see is 7. Oh, wait. The fact that this sees this up here means... Oh, that's forced. So this is 2. I don't think there's any way for this to be greater than 3, right? Just because it's gotta be... this is orange. This is odd, so... What I got here... Oh, well... I can also do some Xing up here. Wait. Oh, three breaks this arrow. This is 1. But now this... Okay, so... Oh yeah, and this... Okay. This has to go up here. So this is odd by the parity. Oh, 7 breaks this arrow, because it would see... Oh, and 7... Now that this is X, this couldn't be 7 anyway. Okay. So this is 3 or 5. Ah, and if this goes this way, that breaks both of those options. So this is 3. So this cannot be X'd. So, the loop ends this way. So I gotta think about connectivity, because the loop has to go down here and then back up, and it can't do it through here. So does that mean both of these have to be... I think the only option now is for both of these to be loop. Which means this cannot be 5, or else it sees too many at that distance. So this is 3. And this is 5. This is not 3, so that's out. And that's X'd, because otherwise that's too many. Okay. So this is 5 or 7. Oh, right. This can't be 7. Because that's gonna... because that means it can't... Unless it takes this, it can't get down here. And then get back out again. Just wouldn't have enough stuff left over. In fact... Oh no, it could do that, making this a 1. So I don't necessarily have to take this corner. Oh wait. This breaks because it makes this a 1. But this is also odd. So in fact, this is 4. And as a bonus, this now has to... I don't want to make a mini loop, so this goes through here. Now this does that. This goes up here. And that settles this as being a 5. And now this, okay. So. Okay, so that's all the odds in this column. Oh, this is even. This is odd, this is even, this is even. Okay, these are both odd. Oh, and this, oops. Makes this odd and this even. Oh, but now this cannot go up. Or or it goes between 2 evens, which does not work. So, that makes this odd. Oh, and this is even by the parity. Oh, that's all the evens in this box. This is 7, 9. All these are 1, 7, 9. I guess I could use uniqueness to show that it does this. Well, not necessarily. Well, yeah, but I don't want to use uniqueness reductions, although it could be fun. Let's see. These two digits are the same as these two, so one of these is 6. 4 in this box goes in here. Oh, this has to be even by, oh, and that's all the evens in this, oh, I can also do a lot of Xing out here. Oh, wait, if this goes up, it has to do that, but then this has no parity, and if it goes down, we run into the same issue with these. So this, oh, and that's going to be the last odd in this box, so that's even. Now, at least one of these two has to be... That 4 was my intended first digit. Oh, yeah, I could have got that right from the start, couldn't I have? Yeah, just from doing this. I wasn't thinking about connectivity at the start. Yeah, if I thought more globally, let's see, what? If this is 9, then this is 9, for what that's worth. Oh. 2, 3, or 5. This is 2, 3, or 5. And it can't be 5 because then this could never get up. So this is only 2 or 3. Oh, wait. If this is 2, there's 3 evens here, so if this is 2, then there's an extra even here which doesn't work, so this has to be 3. Because, like, wherever this... Okay, so this is 4, which makes this 9. That was not how I expected to resolve that, but it's neat. Alright, now, 1, 2, 3, okay, so it's there. And because this is the only remaining even, I can't have any more, so it just does that. So that's odd, that's even. So is that, and I also get this, Ooh, that's... Alright, so how does this get down here? I think... Right, if this goes up, it's gonna... this is a dead end. In fact, I think this has to connect to this, so this has to do this. This goes here. That doesn't tell me exactly how this works, but we'll see. Okay, now this can't connect to this, because they both have to get out through here. Okay, so these are all the same parity. Do I know which parity that is? Oh, but this... Oh, wait, this could... No, this could go down. If that's odd, that is all forced, which makes me suspect that's what it is. Oh, and this is 9. Simply, by virtue of where does 9 go in this box. I guess 3 in this box only goes here. Does that tell me? Not necessarily. There's a 4 in here. Now, if... Oh, if these are all even, does that cause any problems? I don't think so. Oh, there's also the fact that these are either both odd or both even. So this is the opposite parity of whatever these are. Oh, I have all the... Okay, and now, this can't be 2. This is 3 or 5. Because it can't be 6. Oh, and I think it has to be 3, because this cannot... Because I, Hey, Dubious Mobius! Yeah, this has to be 3. And now these can't connect, so this has to do this, and this has to link up here specifically, making this 1. Okay, so this is, okay, so that's gonna get all of these. Okay, so... Oh, and now if this goes down, this has no, Alright, okay, so... Oh, and because of the way this loops up, these are all the same parity, right? Because of this arrangement? Oh, this isn't 1, this is 1. But these are all the same parity and they can't be... Yeah, okay. Oh, and also this, I can't close it here because it needs to... Oh, 3 in this box. So 3 in this box only goes here. There's also a 9 in here. This is 5 or 7. Oh, 7, okay, I've got all the odds here, so this is even. Oh, right, this is, right. I looked at this earlier and then forgot about it. Okay, that is done. This box, can finish that off. Oh, this row. I have all the evens in this row. So that's even. Which makes that the 6. Oh, that's not 6. That is 6. 2, 8 pair here. Gotta watch for that being resolved. Oh, 6 in this box goes here, so here it goes here, and it's resolved by that. Which makes that a 6. This is 2 or 4. And this digit goes here. So it's either a 2 or it's whatever this is. This is 2 or 8, so this is 2 or 8. Now, oh, I've got all, between this gives me the last odd here, so these are even. So this is 2. Oh, this is 8, this is 4, 8. That's 4. 2, 8 pair. Okay, but this is important because now this does that, making that odd, and now this is forced to do that. Neat. Oh, that's 4. Oh. I need one more in this, yeah, the first 3 rows are done. Oh, and now I can't put it between 2 odds, so the loop goes there, and now I'm almost done with the loop. Okay, all the arrows, I think, am I missing an arrow? No. Okay, so all the arrows are done. So now... I guess I don't need to remove all these. I'll just remove a few. Yeah. Okay. Yeah. Okay, so 5, 7, 9. This digit goes here in this box. Oh, this is 1, 5, 7, so that's not 1. Oh, yeah. Oh, and that's 4, that's 8. This 4, resolve that. Okay, so that's 4. This is 2, 6. That is 6. That is 2. And now 8 in this box only goes here, making that 3. So that's done, and that's done. And now, right, this could go here, but then it can never get back. So now the loop is all done. Oh. This looks up and resolves this. And that's that. Okay. So this is 2, 4 resolved. That's 6, that's 2. Evens are done. Okay. Yeah, GG loop. Now it's just the rest of the puzzle. Alright, so, 5, 7 pair here. 9 here. Three here. Oh! 3 in this box. Okay, 3s are done. What about 1s? 1 in this box goes here, makes this 1, makes this 1. Now 1 in this box goes here, so that's 1, that's 1. Five, 7 pair. Oh, that's 1. Ah. Resolved by this. Okay. Oh, 5 in this box. Which means 5 in this row goes here, which in turn should resolve everything. Yeah. Okay. That was neat. Thank you for the crab rev. Yeah, that was really neat. I wish I'd spotted this right from the start. That would have been a really cool break-in. Especially because it would have gotten me this whole cluster of evens right at the start. Well, oh, I might have had to... Oh yeah, to disambiguate this, I might have had to use something else. But yeah. Yeah. Oh, no problem. Thanks for sending it in. This was really neat. Oop. I missed a couple of the X's. Any others? I think that's it. Alright. Oh. Little like a witness puzzle. But yeah, I do like it when lesser known rule sets get used in hybridization like this. That's really cool. Myopia is one of those genres that seems like it just can't possibly work on at first glance, but it has a surprising amount of depth to it. Next up, fold-in Pentopia. Oh yeah, fold-ins. Those were... Oh, I guess it wasn't that long ago. Those were really big. Yeah. All right. I want to try Blackjack Fitz's newest puzzle. Cool. Okay, let me ping Blackjack Fitz. Haven't solved a Sudoku in a while. I remember someone made a Sudoku for the Puzzle Agency Championship, a Japanese sum hybrid. I keep meaning to make something like that. Alright. Sumdoku. Fill each cell with a digit from 1 to 9. Fill every row n and column n with exactly n different digits, repeating digits as necessary. So these are all the same digit, and these are all different, and these are all different. Self-referential arrows. The digit in a cell with an arrow tells you how many steps along that arrow's path until that digit sees itself for the first time. I.e., if row 2, column 3 was a 2, then this must be a 2 and this must not be a 2. A cell with a question mark must have at least one valid arrow. This arrow may be diagonal. Palindrome. Digits along a gray line must read the same forward and backward. Okay, so these must be the same. These must be the same, but these must be different from each other. So that is a bit interesting. Oh. Row 8 can only have one repeat. Column 8, I mean. I think these both have to be 6s, right? Yeah. Okay, and all of the rest of these must be different. Oh, and I should make this its own thing because it's a different color from these. And it is not the same as this or this. Yeah, but this could still be 6. So, okay. So, this is 9, so none of these are 9. Okay, and oh, and since this is not 6, I know all of these are either 6 or yellow. But they can't be... I can have at most one 6 in here, because I can have at most one repeated 6 down here. So at least 4 of these are yellow, which means at least 4. Max repeats here is 1. Max repeats here is 2, 3, 4. In addition, but that's in addition to. I can see at most 2 of the same digit down here. 3, 4, but this counts, so I think the maximum this can be is is 3, right? Because, oh, this being yellow would be very difficult. Okay, can yellow be 1? If so, then like 4 of these are 1s. That might cause problems here. Oh, it could just all be here. Okay, now, I know that these are not yellow, but the question is, are they the same as each other? Oh, wait, this has to be 6, because it can't be yellow, and I know that yellow is not 6, and 6 does go in this row. That said, if this is yellow, these this is not necessarily 6. I know that at least 4 of these are yellow. Possibly quite a few, possibly all 5. Because if I have... I can have at most 1, 6 down here. Is there a reason these all can't be yellow? Then yellow is at most 2. Then these would have to all be different. Oh, that breaks this. But if they're all 1, that works. Like these all being 1. That feels fine. And I don't know, I haven't used up my degrees of freedom in either of these rows yet, so I don't know either these columns or these rows yet, so I don't know that these aren't the same as either blue, red, or green, or yellow for that matter. These must all be different. So these must all be from 1 to 6, and I can have at most 1, 6. So these must all be pretty low. Does the fact that all of these have to be different mean... Does that tell me anything? These all be 3s. It'd be very tricky, but doable. This would have to be a diagonal arrow in that case. But, what about this? What about this arrangement? It'd be easy for these to all be 1s. I'll turn on row column labels just to remind myself of what n is for each row column. Yeah, if I make these all 1s, I will have a room. Then none of these can be 6. In fact, the max these could be would be 4. What about this? Can't be yellow. Can't be... If these are 6... this could still be the 3rd digit. And this is either yellow or this. Now, could... Oh, neither of these can be 6. But they could both be yellow. That's fine. Until we've narrowed down what yellow is. What am I meant to look for? It can't be the question marks. I can't... Those have to just be to resolve stuff towards the end. Because if the arrows can be diagonal... Yeah, if the arrows can be diagonal, that is... Does something break if these are both yellow? What is... I know that these are... What is... If I knew that there was... Can I somehow prove that one of these has to be a 6? I don't see anything wrong with these all being yellow, especially if yellow is 1. Do I run into any issues? I mean, these could be 3, these could be 1. If these aren't the same, I mean, I could put 2s here, and then like, oh, then these if these aren't the same, can these be 3 different digits? I guess maybe that's what I should be asking. One. Four, 5, something like that. Okay, that works. It makes this 1. This is also 1 in that case, but this is only one option. Yeah, I'm not seeing any issues with these being different, at least not immediately. What if these are 2 and this is 4? And this has to be the remaining digit. It could be a 1 or a 3, or this could be a 2 and this could be anything. Yeah, I don't see... Is there something wrong with 4 of these being 2? Then this, whatever this is, has to be the last repeat. Oh wait, that's not even... Oh no, this could just be another 2. Yeah. These can't, all 5 of these cannot be 2. Because that breaks this arrow, or this row. But I don't think I know anything else about what these can be other than that. If this is not 6, don't we get too many repeats in column 7? Oh, this. Right, this would still have to see something, and then this would still... And then this being yellow means there's 3 yellows and 2 of whatever this is. That's too many repeats, right, okay. So all of these are yellow, and this is 6. So that is all our repeats in here. And we know none of these are yellow. So this is a 1, 2, 3, 4, 5 triple. Quintuple, sorry. This is 7, 8, 9. One of them is missing from the row. So I know there's a 4 and a 5 in here. So these cannot all be 1s, because there's a 5 in here, which is going to see a 5 up here. And that's interesting, because, like, this cannot be a 5. Well, I know there's a 5 up here. So yellow is not 1. Yellow is 2 or 3. So there's also a 1 in here, which means there's a 1 up here. So if it's 3, these all have to be different, for what that's worth. So if this cannot be 1. Because then all of these are 1. So either these are all 2s, which is by far the easiest option, or else... Oh, wait. Either these are all 2s, or these are all 3s. If these are all 2s, then this uses up my remaining degree of freedom. Or it could be another 2. Oh, cool. Bye, AQ. Thanks for dropping by. Glad you're done with the dentist. Okay, so this is 2, 3, or 6. And I do get one more repeat here. Oh yeah, what about this? If this is 5... I mean, I guess this could also be 5. It can't be yellow. Oh, but wait, there's also a 4 in here. A 4 in here and a 5 in here, so this can only be 3. Right. And none of these are 3s. Right, and I know there's a 5 in here along with something else, along with whatever... How about instead of coloring these, I say 5 is pink and whatever else is in here is blue. Oh, in fact, I know this is blue. Oh, and this can only be 1, 2, or 4. So these are all done. These are all different. So I might be able to get something... Well, I don't know that this isn't blue. Making these 2s would be easiest. I would make these 5s. Oh, and we're almost out of repeats here. In fact, this becomes the last repeat. Either 2 1s, 2 2s. Oh, wait, it could be 3. Oh, either way, that's still... Wait. Yeah, so either way, this is the last repeat. This still could be 3, though. Oh wait, no, it can't be, because I can't repeat a 3. None of these can be 3. So... this is the last repeat up here. Whatever this is. So I know that this is not blue. I'll make that green. And I know that this is not blue. Or yellow. I'll make that pink. So there's a 1 here, a 2 here, a 4 here, and a 5 here. Wait, if this isn't blue, it's 5, and then neither of these can be 5, so blue. So this can't even be 4. This is only 1 or 2. And it goes in here with... Wait, if these are 2, this is 5, and this breaks. So I think this does have to be 1. And now So this is not 5. One 5 pair. Oh, this can't be the 1. This has to be the 1. And this has to be the 5. So that's, yeah. So, right, and I know that this is not the same as this, so this is not 1. So this is something else from pink or green. I'll make that red. Oh, this is not 2. This is either 3 or 6. Oh, but wait. This is 7, 8, or 9, which is not 3 or 6. So this is 3. This is this. Okay, so this is a 7, 8 pair. You gotta remember that these are the same and this is different from that. So, where does... I still haven't gotten my next repeat here. So, that is a little... annoying when I'm... Okay, so these are all from 1, 3, 5. This cannot be 1 or 5. This is another 3. And this is not 3, so it's 1 or 5. This cannot be 3, so it's also 1 or 5. Oh, but it can't be 5, because that breaks this, so this is 1. But that... this is still the first 5 this sees, so this doesn't... This could still be anything. Then there's... two, okay, okay, so 2 of the 3 digits in this column are 3 and 5. And if this is not 5, it is the other one. If this is 1, 2, or 4, that becomes... oh, wait. No, wait. This is 5. Duh. Okay, so... one of these is a 1. If it's that one, the question mark is resolved automatically. So I'm guessing it's not that one, just because there'd be no way... oh, unless making this one is the only way to satisfy this. Okay, wait. 3... either this is a 3, or these are all 7s. Now, if these are both 3s... oh, it is? Oh, yeah. Right, it can't be 5 or 3. Oh, the only option is a 2. Because 3, it can't be 3. If it's 4, I'd have to put a 4 here. If it's 5, I have to put a 5 here. That breaks this. So this is 2, and this is 2. These are all from 2 through... Oh, this cannot be 5 because of this or 3 because of this, so that's 2. And the only one I don't know is if this is 2 or 3. I know that that becomes a repeat here. This is 3 or 7. Oh, this is 7 or 8, whichever of 7 or 8 this is. This is also 3 or 7. Okay, so 3 of the digits here are 2, 3, and 4. And there's no 3s here. If this is 7, then none of these are 7, so all of these are 2 or 4. What else do I get from... And at least one of these has to be a 3. Oh, but wait, this can't be a 3 because this can't be a 3. This is 7. This is 7. Okay, so now this becomes a 3. So that's not 2. So now these are all 7s. And this is the only one I don't know about. This is 8. I still don't know about this, interestingly enough. Okay, so these are all either 2 or 4, because they can't be 3 because of these, and they can't be 7 because of those. So these are from 2, 4. And I know there's at least one 4 in there, which pairs with a 4 down here. And I've got all my repeats here. So these are also only from 2, 4. So what is this digit? Oh wait, no, this could still be a repeat. This one can't. But I could make this one a 3. Oh, 4, wait. This cannot be 1 because 3 1s and 4 3s, that's only 2 distinct digits, so I can't get to 5. So this is the 4. Now, interestingly, that doesn't mean that none of these are 4, that these aren't 4. In fact, these all have to be different, right? Yeah. So this is not 1. Oh, this is 1. This is 1. I have one more repeat in here. Oh, and since this can't be... this is 2. Okay. So this is not 2. This is 4. This is... Oh wait, this can't be 5, so this is 8. Okay, so this is not 8. It can still be any of 5, 6, 7, or 9, because I still have... Okay, these can only be 2 different digits. So these all have to be different. They can't be 2, and they can't be 2 or 3. Oh, wait. These are all different. Wait. These can't be 1... This can't be 1, 3, or 4, right? Yeah. So this is only 5 or 6. Two, 5, 6, 7, 8, 9. But a question mark can't have a 9. For what that's worth. These are 1, 2, 4, 5. So 2 and a 4 in here. Alright, but the fact that I have 5 from 2, 3, this cannot be 2.
So, it's all about trickery to you? Wherever have you come from?
No.
Question mark can never have a 9. In fact, a question mark this close to the middle of the board can never even have a 7.
Our hands are no longer tied. Where are we?
Well,
Oh, and this one can't see a 6. It would have to be here, here, or... Oh, even this isn't far enough.
Right here.
What a silly
Right.
place.
Can't even
It's
see a 6.
stuck.
Okay.
So it's not real for now?
If this is
I don't
5,
think it has
it sees a
started
5
yet.
here.
Doesn't matter what
Oh,
it's
but
made
that
of.
breaks.
It's definitely struggling. We need to perform sectio transversalis. Cut the wall. There's no other way out. What else is there to do?
I know what to do. Those who favor hard logic and
Oh,
direct
and then it can never see a
action
4.
are
This is a
bound
1.
to be misguided.
So this is not a
Only a
1.
miracle
And
can
now
set us free
I
without
got
us
so
having
many
to
1,
destroy
3s, I
something.
need 2 more distinct
And
digits.
I can do miracles. Just let me.
Will you
4,
please
5,
keep
6,
quiet? You're
7.
a liar and a thief.
Oh, this is
Who
not
going to
7.
believe you when you keep lying to yourself? The truth is my shepherd. Whatever happens, I will find answers.
1,
And just
4,
as for
5,
Spirit,
6.
I will perform the operation. Medica morbo adhibe.
Don't you go all bossy on me, clever clogs. You will act justly, but you're
I
just
still
as
get
not
one more
blind to
repeat
have become
here.
his demise.
Oh,
This
this
calls
is
for the gentle
also...
hand of a
Oh,
surgeon.
this is only 1 or
Step
4.
aside, both of you.
Your gentle hands are used to killing, not giving life. You will inevitably do harm. As for Brainy, he has no regard for casualties at all. Neither
This
of
cannot
you
be
knows
6.
compassion.
So 6 in this
Yes,
row only
it
goes
seems
here.
unlikely that we'll get along well, but there's only one truth.
Any choice is right as
These
long
are
as
all
it's
from
willed.
1, 3,
That's the truth of the
4.
matter.
Only the heart
So
will
these
show
have
you
to
the
be
right
distinct.
choice. Stop thinking about yourselves. Think
Max
of the
this can be a
sick.
6,
He's in
and it
pain.
can't be 6
I
because it can't
see
see a
it yet, but I
6.
can feel
Can
it.
it see a
It's not
5?
even a trap.
No.
It's
This
a
is just a
flame.
2.
Subipsum funis sumus. Can't say I hold a soft spot for it.
Oh,
I
it's
can
see.
see
Okay,
that.
so this is
You're
satisfied.
full of hate. Stuffed or not, it's breathing. I can hear it.
1, 2, 3, 4.
It
This
can
is
be
from
healed
5 or
rather than
6.
killed.
You
Okay.
mean you won't become a
Um,
killer? But you will. Mark my word, that's exactly what will happen. But I can avoid it.
No,
Uh-huh.
we won't ever get along.
Oh, right. It
I
can't
suggest
see
we
a
go
4
our
over
way.
here because that
The sooner
breaks
the better.
this.
Off we go then?
Let's go. The clock
Because
is
these
ticking.
block the view, as it were. Right, this has to be a 2. Now, how can I ever... Oh, this 3. Duh. This 3 resolves that. Am I missing that anywhere else? Oh, this is not 5. So this looks up, makes this a 2. And now this is 3 or 4. It sees 3 fine. Can it see 4 anywhere? Everything else is off the grid, so no. This is a 3. And now I have my remaining repeats. So this is not 5. This is not 5 or 6. And this is 4. This is 1. Oh, and this is 5. We have... Still only... Okay, let me... Can this be a 5? It cannot. Can it be a 4? No, it cannot. So this is only 1 or 2. If it's 2... It's there. Oh, and if it's 1, it breaks, because I can't have any more repeats here. So this is 2, seeing a 2 there. Okay, so now I have all my repeats. So this is 7, this is 9, this is 5, 4, 1. Okay, this is not 1, 2, 3, 4, 5, 6, 7, or 8, so this is 9. Huzzah indeed! That was neat. Glad some dokus are back. These get really cool. No, hi Stu. Currently packing to visit family, but you're welcome for solving arrows. And yes, this was much fun. I like it. Okay. Need to refill my water again, and then I am going to try this juggler puzzle, which got featured on CTC the other day. Let me ping juggler. Alright, be right back. Alright. Very simple rule set. Place the digits 1 to 6 once in every row and column. Every cell has exactly 2 orthogonal neighbors that differ from it by at least 3. On the gray line, one cell is the sum of the other 2. So every 3 is bordered by 2 6s. And every 4 is bordered by exactly 2 1s. So, that's gonna be like, okay, let me think about how this works. Like, if this is 4, then these are 1s and these are 1s. And similarly with this being 3, these being 6. But I can't do that both ways. So, okay, so, I guess one way to think about it is in every row, the 4 always borders the 1. Same in every column. And the 3 always borders the 6. So one cell is the sum of the other 2. So if, for instance, I put a 3 on here, can I put 2 3s into 6? Oh, this actually works. And then I put... Oh, but wait. This 3 needs to border the 6 in its row and its column. So, right, so every 3 borders 2 6s and every 6 borders 2 3s. So don't I need to make these square configurations? Like, say, if I put 2 6s, don't I need 2 3s? Cause... Or wait, or does that work? Ah, but then I run into a wall here, right? Right, and now I can't place the other 6. Right, yeah. So I need to put the 6s and the 3s in these little square configurations. Same with the 4s and the 1s. So I need to... Right, it either goes like that, or like that, or some rotation or reflection of that, and same with the 4s and the 1s. So, that leaves the 2s and the 5s next to each other. Oh, and the fact that... The fact that the 6 has to go next to... Here, let me... I think I can divide the grid into 2 by 2 squares. and say each of these squares is either all 1, 4, all 3, 6, or all 2, 5. So, what do I get here? 2, 5, 3. Is that the only thing that works? If that works at all, it pretty much has to, right? Can't be 3, 6 with another 3. Oh, it could be 1, 4 with a 3. Does this always have to be a 3? Oh, but wait. These have to be the same. Right. Oh, okay. No, I had it backwards. These always have to be the same. So this has to be double that. So it could be 1, 4, 2 or 2, 5, 4. And this is either 1 or 5. And these have to be different. So how do I get one of these in each? Yeah, blue in this mini row has to go up here. Oh, wait. Okay. So these are 3, 6. And now, this cannot be 6. Because 6 can only go next to 3. Okay, these are 3. These are 6. This is 4, 5. But this has to be 5. So this is 3. This is 6. So this is 1, this is 4. Cool. Thanks for the GGs. That was really neat. Do I want to add another 3-star? I'm only 3 hours in. I got one more in me. Sure, I'll do Schrodinger's Carry-On. Amazing that I was not expecting this to be 2, 1, 1. It doesn't feel like this should be possible just from that. Yeah, that's impressive. All right, let me go through this 3-star real quick. Also, let me ping James Sinclair. Sorry, I was replying to a question about a puzzle. Alright. Let's try this. This is Schrödinger's Carry-On by James Sinclair. Fill each row, column, and box with the digits 0 to 6 once each. Exactly one cell in each row, column, and box is a Schrödinger cell, which contains 2 digits. 2 Schrödinger cells cannot contain the same pair of digits. A cell's value is equal to the sum of its digits. For solution check purposes, if a cell's value is from 0 to 9, enter the digit equal to its value, otherwise the cell may be left empty. Okay. Interesting. Cells with red squares are index cells. If an index cell in column X has a value of Y, then the cell in column Y in the same row has a value of X. Oh, hey! Hey, James, welcome in. I.e., if row 3, column 1 has a value of 5, then this has a value of 1. An index cell may contain 2 digits but cannot have a value greater than 6. If an index cell has a value of 0, the value being indexed does not appear in the row. Nothing in these rules prevents a value from repeating in a row, even if one instance of that value is referenced by an index cell. The sum of the values along an arrow is equal to the value in the connected circle. Note, because of hard-to-explain issues related to the rule set, in-progress solution checking doesn't work properly in this puzzle. Well, that's interesting. Okay, so... So the issue is... Okay. If there's a value of 0 here, if there's a 0 that is not part of an S cell, then the 1 in that row is in an S cell with another non-zero digit, but of course if the S cell is 0, that's fine. But then... What does... But, of course, the 0 could be in an S cell, in which case this is all just... In which case this is just a normal thing. Same here. And there's nothing in the rules that says it can't appear on an S cell. Okay, let me look at this. This, I guess this could be 0, 1, 0? I mean, this could be 1, 2, 3, 4, 5, or 6. I know this doesn't have a value of 0, but... Oh, and 2 Schrödinger cells cannot contain the same pair of digits. That is good to know. So this either digit or 2 digits. And of course, the max value this can have is 6. So I can't make these too high. The issue is, it is very difficult to see where to... where do I start here? Because, like, this value in this box, obviously, I mean, if this is a single digit, I know it doesn't go here, especially not in an S cell. It could go here or here. Am I supposed to do, like... These arrows are... I mean, I know this has a value of 21. So these have a value of 21. Now, I can only have 1 0, at most 1 0 in each of these columns. So if... Okay, assuming there is no value of 0 in this column, I have to split these duos up by polarity. So, like, one of these must be from 1, 2, 3, the other must be from 4, 5, 6, if there's no 0 here. And if there's no straight 0 here, I must do the same here. Why would... So, like... But if I do use zeros, that doesn't tell me much. If I use zeros in one of them, I don't see... And like, the 3 or 4 digits here must be the same as the 3 or 4 digits here. So, if this is... This being 2, this being 1. 2 and 1 up here. And then this has to be 4, 5, or 6. But again, that's only if... If I have a 0 here, the S cells can have a max value of 6, so I can never put a 6 in an S cell unless it goes with a 0 in this column. Same here. So, and I can't have 0, 6 S cells in all of these, so in both of these. Sorry. A 5 can only go with a 1 or a 0. Am I... I wonder if I'm... missing something obvious here? Because I don't think... Cough drop. So I know there is at least one 6 here. And there can't be 2 6s. I can't... Oh. Right, because the value of an S cell can never be 1 unless it contains a 1 and a 0, or 2 unless it contains a 2 and a 0. I can't repeat values in here. So if there is a 0 in its own cell, what are the rest of the values? Yeah, there's always going to be a repeat, so I can't put 0 in its own cell. It has to go with something, and same here. It has to go in the S cell. The 0 always goes in an S cell in this column, and same here. Okay, so we are back to this being at least 3. And also... yeah, we are back to this being the values 1 to 6. Max digit I can put in any of these is a 4. No, wait, this... oh, wait, this can't be... this can't have a value of 1 and 2. Because the 1 would force another value of 2 over here, and I can't repeat values. And I have the values 1 to 6 here. I can't repeat values in this 2 by 2 area. Even with an S cell, especially not a value of 1 or 2. So I don't think this can be 3 either. So the 1 goes in here. I don't know if it goes with... and this has a value of 1, 2, 3. How on earth am I going to actually, like, resolve where the zeros go? Is the twist going to be that, like, this is that there's no zeros in the entire puzzle? Because, like, a cell's value is... if for solution check purposes, if a cell's value is from 0 to 9, enter the digit equal to its value. So I'm wondering if the joke is going to be that there's no zeros in the puzzle anyway. Okay, but what is the minimum this can be? 1, 3? Yeah, 4. So this has a value of 1 or 2. So this has a value... And in fact, since I know that... Why don't I just omit the zeros here for now anyway? Because... Oh, but wait, 1, 2, 1. Yeah, this could never have been a 4. It's 4 I just ruled out of here. Okay, so there's a 1 in here. It might go with a 0, it might not. In fact, I can never disambiguate. I'm always going to get an X-wing on S cells here that I can never disambiguate. So there's no real point to pencil marking a 0 here anyway. Oh, and there's also the fact that one of these has to be at least 4. Right, this is a 1-4 pair. So no 1 here. No 6 here. So there's a 2 here, making that a 3. And there's also a 2 here. There's now 1, 3, 4, 6. So this is a 2, 5 pair. This is 3, 6. Oh, this is 4. Oh, this is not 4. This is 4. Two, 5. Now, hold on. This doesn't mean... Oh, it does kind of mean that... Because I do have these digits... Okay, so these are going to be the values. So I do have... Yeah, because of this... Well, no. I could put a 0 here and then a 9 here. So I think... This is forced. But... Oh, and so is this. But because nothing indicates a 3 in either of these, I don't know for certain that one of these doesn't contain, that this isn't a 0 and this isn't a 9. I will probably find out that does something else for some reason, but okay. What about, oh, this 6 makes this a 1. And this is a 1. Now, right, there's no way to have a value on here. This cannot be 1. Wait. Oh, yeah, and there's no way to have... There's no way to have a value of 2 that isn't a 0, 2. So this... Okay, so this is fine. And now we have some combination of 0, 3, 6 here. Oh, but wait, this cannot be 0. So this cannot be 9. Okay, so we're back to having no... Right, and I can't have a 1 here. There is definitely a 1 in this cell. So I can't make a value of 3 without a 3. So this is... Oh, I'm sorry, there's one more rule. Digits can't repeat within a cage. To check your solution, delete the digit in every cell that contains 0. Oh, wow. Okay, so I have to find a disjoint set. One in here, and one from 1, 2, 3, 5 in here. Huh, okay. So basically this is just find a disjoint set that has no more than 1 in here. More than 1 in here, no more than 1 in here. 1 in each row, column, and box. Huh. That is... Let's see, how do I go about this? Okay, well, the one in here... I know there's at least 2 in here. Because there's 3 in this column, and... Oh, wait, it can't be here or here. Because if it is, I repeat it here. Yeah, I know. I worded that poorly. I know I don't know. In fact, I know I can't have it here or here. Okay, I'm going to green out everything that isn't an S cell. So one of these is. And if it's here... then that's also it. If it's here, that's also it. Here, there, and here or there. So in these, if I, yeah. So I know there's one here, so I know there isn't one here. Oh, and it can't be here, because that's it. Okay, so this is an S cell. I'll mark that to remind myself to delete it. And now no other 5. Okay. And nothing else in this box. Okay, so there's a 4 or a 6. So, if that's pink, then one of these is pink. Don't know if that's bad or not. What about... If it's here, then this is pink. Oh, if this is pink, then this is pink. Then this is pink. Then this. And this. Okay. That seems to work. What about... So that must... So that's presumably it. So now... Oh, this cannot be pink. Okay, so... If this is pink, this is pink. Can I do that anywhere else? Like... If this is pink, this is pink... This... Oh, that forces this. So this is not pink. Which means none of these are. This cannot be pink, because then I can never have one in this box. This cannot be pink, because then I have 2... Okay. 2, 6, 3, 1... Either way, this is pink. No matter how I resolve that. Okay, so... so no more 6s. Okay, so one of these, so this, okay. There, that gets me that. Okay. Okay. Congratulations! If you were expecting this to all lead up to some pseudoscientific battle about the puzzle being simultaneously solved and unsolved, sorry to disappoint. It's solved, full stop. Huge thanks to Wiggle for programming the cage reveal trickery and for helping with the puzzle itself. Oh yeah, that is... Okay. That was neat. Cool. Yeah, that was a neat little thing, yeah. Alright, let me see who's under raid. Alright, I will be back on Saturday with more, Seance of Blake Manor. Oh god. Okay, I've been raiding Chatty Cathy a lot lately, but she is doing, another favorite game of mine. Lies of P. Alright. This was fun. Got through 6 puzzles in less than 4 hours. I call that a good one. Alright. Be back on Saturday with Blake Manor. Monday I'll be starting Rorschach's River. And yeah, thanks for joining me, and bye!